Hello everyone! In this video, I'll be presenting my project titled Smart Recitation Student Picker. The goal of this system is to help teachers select students for recitation in a fairer and more balanced way instead of relying only on random selection or memory. I'll first explain the technical parts of the code, including the machine learning model and how fairness is handled. After that, I'll demonstrate how the Gradio app works and show the difference between machine learning-based selection and random selection. So I'll start with the dataset used in this project. Each row represents a student, and the dataset includes the student's name, section or their group, number of times they have already been called, days since they were last called, and a participation score. This data is manually created to simulate a real classroom environment using sample names from the internet. Since this project focuses on fairness, these features allow the model to understand which students may be under-participating. Before training the model, the data is cleaned to ensure consistency. Duplicate students are removed if there is, missing values are filled with reasonable defaults if there is, and data types are corrected. This step is important because machine learning models require clean and structured data to work properly. Next is feature engineering. In this project, I compute a selection priority score, wherein this score is not a real-world label but a rule-based target that reflects teaching priorities. Students who have been called fewer times and those with lower participation scores are given higher priority. This allows the machine learning model to learn a ranking pattern that supports fairness rather than predicting an external outcome. For the machine learning model, I use a random forest regressor. This model was chosen because it handles nonlinear relationships well and works reliably on small datasets. The model is trained using two main features, which is the times called and the participation score. The output of the model is a predicted priority value, which is later used to rank students during selection. Feature importance is also printed to show which inputs influence the model's decisions the most. The project also includes multiple visualizations to help understand participation patterns. These charts show distributions of participation scores, how often students are called, engagement trends across sections and such. And to measure fairness, I use participation variance, wherein a low variance means students are being called more evenly, which indicates a fairer recitation process. This metric helps compare the effectiveness of the machine learning-based approach against random selection. So this function controls how a student is selected. When machine learning-based selection is chosen, the model predicts priority scores for students in the selected section. The system then randomly selects one student from the top 5 highest priority candidates. This keeps the process fair but avoids being too deterministic. After a student is selected, their data is updated so the system learns over time. Now for the user interface. The user interface is built using Gradio, which allows the model to be interacted with visually. Users can select a class section, choose between ML or machine learning based or random selection, and then click a button to pick a student. The interface also displays fairness metrics and updated visualizations after each selection. I'll now demonstrate the system using ML-based selection, wherein after clicking Pick Student button, the system selects a student and updates the fairness metrics and charts. Over time, you'll notice that students who are called less frequently are prioritized more often. Now I'll switch to random selection. In this mode, the system selects any student without considering fairness. This comparison helps show why the machine learning-based approach is more suitable for balancing participation. To conclude, this project shows how machine learning can be used to support fair decision making in an educational context. Although the system was developed under platform limitations such as Kaggle's restrictions, it still demonstrates learning over time, fairness evaluation, and practical machine learning usage. And that is all for this technical and walkthrough video. Thank you for watching.